Back when we copied from the text file and we pasted it in here, I'm just going to reassure you that we copied and pasted from the same text file. There was nothing different about mine and yours. And I'm going to explain why this idle tap is here. This could not be found. Well, back in the beginning when I was defining the animations, I made this lowercase because I decided that I want everything to be lowercase. But in our script it actually is uppercase right here. So we can either rename our animation or we can change it in the code. I'm just going to change it in the code. So click on the animation state reference. It says that line 133. Okay, there we go. Change it to a T, change this to a T. So that should get rid of that null reference exception, in case we were worried about that. So I'm going to continue explaining in the function update. We got to right here. So, actually no, we got here. Okay. So yeah, if we press that action button, we play that animation right here, and then we use T, and we don't let the user press the action button and play that animation until time is greater than T again. Well, minus 0.5. That's just so it's a little more smooth. So after time is greater than T, we can play that animation again. Then we make the can animate false until it is true again. So back up when we defined T, we said T is equal to the animation selected, the clip length of the animation selected, plus time. So it adds time plus that clip length. So whatever the clip length, it's going to have to wait for time to catch up, and that's how that works. If we don't press the action button, then it's just going to play the idle animation function. Idle animation function is pretty straightforward. Basically, it's going to check if time is greater than next load. Next load up here I defined as 0. So when it first starts, time is always going to be greater than 0. So we don't have to worry about this right now. It's going to return true. The flag idle equals false right here. And I'll search for the next time. Flag idle. So there's no definition that flag idle equals true in between here and the idle function. So this is going to return false at first. Then it's going to go to here, which then it makes it true. So after it makes it true, it'll return, and if it's true, it'll go false. and it switches like that. Also, no matter if the flag idle is true or false, it's going to make next load plus the rate and plus time. The rate is 5. So it's going to wait 5 seconds. Remember how this was 0? Now it's going to be 5. Time has to catch up with 5. And then goes through this cycle again. At the same time, it checks if flag idle equals true, and if it is, it plays the idle animation. But if it's not true, which it won't be for 5 seconds, it's going to play the idle tap animation. And that's just a different idle, just to mix things up, just to make the idle animation look a little better. So it plays this, and then it checks if it's not playing, make flag idle equal true. So it plays it, and then checks as soon as idle tap is done playing, makes flag idle true. So idle animation function is just one huge loop that keeps on going on and on and on. And that's only if we're not pressing action and we're not pressing any of the above. Down here, we also check if we're not pressing the action button again. So, if we are grounded and we're not pressing the action button, where am I? Right here. If we're not pressing the action button, we need to make the move direction equal to 0, 0 to get axis in the vertical. Down here, we use the move direction to move our robot controller. So if we're not pressing the action button, we're going to make the Z part of our vector equal to input.getAxis. We're also going to make the move direction converted from local to world space. So that's what the transform direction function does. It takes the move direction, which is a vector 3, and makes that world space. And how that works is this. Get rid of this. So right now, we can see we're in global rotation space. But if I rotate my character, look, he's facing this way, but our blue arrow is still facing forward. And that's what world and or global means. Is that it's just going to be not relative to its rotation. But if I click on this and make it local, rotate it, go back to the move, there it is. This is the local transform of our character. And we don't want the local, because if our character is looking up and we're pressing the forward button, he's going to transform in a diagonal direction. So that is why that line of code is there, converting from local to global space. So then we multiply move direction by the boost increment and by speed. Speed equals 12, and boost increment equals 1 if we're walking, and 3 if we're running. So that's how we get our move direction. And after all this is called, so if we're not grounded and we're pressing action, we can still do the action. It's okay. Oh yeah, jump. Here's a new one. We already have jump set up. It's already defined in Unity, and it's space. So if we press space down, then we're going to crossfade the animation jump. Also, we're going to make the move direction.y equal to jump speed. So the y, which is up and down, that's the y, is going to equal to jump speed. And jump speed is to 10. So we're going to go up to 10 in our world. What else? So this is outside of every if statement. So this is going to be called every time update is called. So transform.EulerAngles.y is plus or equal to input.getAxis horizontal. So far we've only been working with vertical, which is up, down, WS. This one's vertical, left, right, A and D. What Euler angles are these. So this looks like a vector 3, our rotation. And what Unity calls it is Euler angles. The dot y component of the Euler angles is this right here. So this transform is going to be added by whatever value the horizontal gives off, because all axes give off a value. And then it's going to multiply it by 5 to make it more sensitive, because we don't want to be turning forever. So that's why we multiply by 5. Move direction.y is minused by gravity times delta time. And this line just basically sets up gravity, because right now we don't have a rigid body attached. That means we have to simulate our own gravity. So we can just go minus gravity, which is 40. So every time the update is called, we add a force in the negative 40 direction. And the reason why we multiply gravity by time.delta time is because what delta time is, it's the value that it took to render the last frame. And this is usually a very, very small number. It's actually a float value. This ensures that every computer makes it so gravity is equal to the same thing. So we're not traveling really fast on a really fast Pentium 4 processor, and some other guy with a Pentium 3, his gravity doesn't react the same. So that's why we have delta time. And we also do it the same in our move because we don't want to move faster than our Pentium 3 processor. So the robot controller has a move function on it, and the move is a complex function. It basically takes a direction and you need to multiply it by delta times so everything works good. There's also a function called simple move, but that just moves it with speed, and that's not what we want for this. You can find all those functions and even more in the scripting manual. Actually, I think it's the reference manual. This is the one I use a lot. Nope, I was wrong. So I go help scripting manual, and in here I search move, character controller.move. Well, there we go. It gives us a full example of how we use the character controller.move. Looks kind of like ours, doesn't it? So if you're ever having any problems with the functions I'm using, that's a great resource. And I already explained the idle animation, and I explained the do action. So it looks like we're all done with this character logic. I'm going to go in one more time, and I'm going to move around. So when I press AD left or right, that's the horizontal axis. So you can go and draw a flat plane horizontal. So our Euler angles are being modified directly by this value. When I press up, a lot of things are happening. It's checking if we are pressing up, making the walk animation dot speed equal to 1. It's also using speed, which is 12, to move our character forward, and it's also checking if we're pressing shift, which is our boost action, our boost input. So if I press W and I press shift, oh, that didn't work. Looks like Unity is giving a reference exception right here. Line 26, so our character logic. There we go. That was a capital T, we wanted it lowercase. See if we can run now. Walk forward, press shift. Nope, doesn't want to run. So what we gotta do is we gotta take this if and put it outside of both of these. So what I'm gonna do is just go cut, Control X, and on top of everything, Control V. Oh. Okay, so it's going to be checking if we're pressing boost down, but instead of playing this run, we're just going to flip a flag switch, and we're going to call it run. So let's go up to the top and add a private variable. Call it run. This is going to be a boolean, and by default equal false. Take the inside of this if, cut it, and go if run, and do these two things: crossfade run and make the boost increment equal to 3. But right now run equals false, so what we need to do is, if we're pressing this boost, make run equal true. So the reason why we need to take this and put it outside of all of this is because Unity is checking for too many things with the inputs. And especially because it's in the update function, it can't be doing all that work. The update function is very vital, especially when keeping high frame rates. So if we press boost, run is now equal to true. But what if we want to stop running? Well, what we gotta do is else if input.get button up boost run equals false. So right here run equals true if we're holding down boost, but when we let go of boost, we're not going to be running anymore. And if we press Control S to save it, that should fix our problem. Control S to save our scene. Unlocking, press boost, there we go. Now he wants to run. This is great. Now back to the idle animation. Right now, for 5 seconds, he's idling the regular one. Then he switched over to the idle tap. So he plays this idle tap for 5 seconds, and then goes back to the regular idle for 5 seconds. It just keeps on doing this loop until you press another button. And I showed you how Alt works. You can go ahead and test all these animations out. They're really cool. And that's about it for our character logic. We can run, do all these cool animations, and in the next section I'm going to be telling you about this punch animation. So what we're going to do is we're going to create a cube, attach a rigid body to it, and then we're going to punch it. And then at first it's not going to work, but I'm going to create a script to make it work, and it's going to be really cool. So let's get started on the next section.